Welcome to Khetz Tutorials, and in this video I'll be covering question 25 from A exercises in James Stewart calculus. Now, this type of question is one of my favorites because there's a cool trick which you can always use. So there are quite a few ways to actually solve this, but all of them basically revolve around critical values, and critical values are just, so this is a quadratic expression, and critical values are just the values which you'd give as the root or the x-intercept, right? So if you were to solve this, you'd have x equals 1 as well as x equals 2, but this is not an equal sign, so you're not necessarily trying to solve. You're trying to give a range of values or an interval which satisfies the inequality. Read in another way, this is basically asking you, where is this quadratic equation positive, or where is it greater than 0? If you were to look at the graph itself, perhaps it would look something like this. So they're asking you which part is above the x-axis, because that is where you have positive y values, right? So that's another way to read this. Okay, so you can use the graph to solve this, or you can just quickly use this trick which I like. So on a number line, you're going to first find your critical values which are associated with the roots. So that's 1 and 2, which you already found. Then from these critical values, you're going to pick a value which is less than 1 or less than your first critical value in between the critical values, and one which is greater than the other critical value. In our case, let's pick a number which is less than 1. Let's say 0. It's a simple enough number. We're going to substitute that 0 in here. So you're going to say 0 minus 1, which leads to minus 1. 0 minus 2 leads to minus 2. So if you multiply these two, we're just interested in the sign, not necessarily the value that it produces. So any number which is less than 1. I just chose 0 because it's simple enough. So now if you multiply these two, you're going to get a positive. And that's what I'm going to indicate there. I have a positive. Okay. Then if I pick a number which is between 1 and 2, let's say 1.5. If I pick 1.5, then in here I'll have a half. So if I substitute it there, 1.5, I'll basically have a half here. If I put 1.5 there, I have negative a half. If I multiply these two, the sign will be negative. So in between, I have a negative sign, right? Then I'm going to choose yet another number which is greater than 2. So a number which is greater than 2, nearest one, 3. If I substitute 3 in the first bracket, I will have 3 minus 1, which is 2. In the second one, I have 3 minus 2, which is 1. If I multiply these two, I get a positive answer. So there I have a positive answer. All right. So maybe this might be a bit confusing because I used the same color. So let me just do that. So now the question says, where is this positive? Now I'm just going to go to my number line or my little trick which I used and check that. So this is the positive section. That is also the positive section, but this portion is negative. So to answer the question, I'm just going to look at the sections which have positive, and that is anything which is less than 1 and anything which is greater than 2. So my final solution then is x less than 1 or x greater than 2. And these are my solutions. And we can verify this. We actually did, so we don't really need to do it again. So as we computed whether these portions would be negative or positive, you saw that the answer, so in this first case, this is positive 3, which is this section, so that passes. And in this middle section in here, we had a half multiplied by negative a half, which is negative 1 over 4. So that fails, and that means that this is still true. And finally, if you try 3, this is what we're going to have. The answer is 2, which is positive, which means this section also passes. So your answer is x less than 1 or x greater than 2. And you can use this little trick to just pick numbers in each interval that satisfy whatever is being asked for over there, and that would be your answer.